Okay, I'm gonna just walk through the projectile motion review key. So this first one's kind of the standard one where I'm throwing a water balloon off of a building with a certain height, velocity, and angle that are all given. And I want to ask all these questions. So the first thing you probably want to do is just write out the standard position equation for the height. So we know y naught, we know v naught, we know the angle, and then we know what gravity does, right? We know gravity is going to accelerate us down at a rate of 9.8 meters per second every second we're in the air. So if we graph this in our calculator, we get a y versus t graph, and we can find lots of things, right? We can find the total flight time when y is equal to 0. So you're just going to find the x-intercept in this case. We can find the maximum. Our calculator can find max values for us. So we can find the time we're at a max height, which would also then tell us the max height. So how long is in the air? We get it from the graph. How far does it actually go on the ground? Well, we know that x equals v naught cosine theta t, right? Horizontal distance is horizontal velocity times time, but now I know the time it's in the air for. So then I actually know this particular t, and I can find the distance. Final velocity, okay, remember final velocity is a vector, so I need to know horizontal velocity and vertical velocity. The horizontal velocity never changes in projectile motion. It's just v naught cosine theta, which was given. The final vertical velocity, I want to use this equation, right? The final vertical velocity is v naught sine theta, original vertical, minus gt, minus gravity's influence for time, but I know the time. It was 4.792 seconds. So I just plug in to find that value, and then I do the Pythagorean theorem and inverse tangent to find the actual magnitude, meaning the speed of velocity, and then the angle. Max height, right? I already found that. That was a calculator question. You could use v-squared equation if you didn't want to graph it, lots of different ways. How high is it when it crosses a horizontal distance of 10? Okay, so what I did is I let x equal 10 in the standard position equation like this, and I found a particular time. So I know it's covered 10 meters horizontally with this time, and I took this time and I plugged it into the y equation. And actually I did it on my calculator. When does it have a height of exactly 20 meters? Okay, that's just me graphing. So you still have this graph, and then you graph y equals 20, and then you solve for the 2 times, right? Y equals 20 is actually above the starting height, so it's gonna pass it, and then it's gonna fall and pass it again. Okay, so that's that first one. Second one is, this is kind of what the lab setup was, right? So I fired something straight up, I fired it horizontally, and I fired it from an angle. And again, it was a ground to ground. So I kind of used the 3 different ways to do something. If I'm firing it straight up, I know that it takes half the time to reach max height, and I can figure out vertically how fast I fired it. But the entire gun is firing vertical. So the vertical velocity is the actual velocity of the gun. Horizontal fire, only the height of the table tells you the time. And then the time can tell you how far it must have gone given a velocity. So we actually just work backwards to find v naught. And the third example, I used the range equation because I had symmetry, right? This is nice and symmetrical here. And so I can use the range equation. So if I know the angle and the horizontal distance it went, I can use that to find the initial velocity. Okay, so that was the first page. Second page, remember number 4, I used the target equation. Why? Well, because I wanted to go a certain distance and be at a certain height, and I knew the velocity my cannon fired. And so I graphed it and I found these 2 solutions. Okay. This equation is not something you have to memorize. That is easily derived using the standard position equation, right? X of t and y of t, and then all you do is substitute, solve for t with x, and then substitute into y, and you get that equation. Okay, number 5 is the ramp question. And remember, there is a relationship here that I've discussed, that the ramp angle here is not the same thing as the launch angle here. This launch angle and the ramp angle are different. This is, the target equation. And the only thing that you don't have is you don't have v naught, you have v naught, you have the angle. You just don't know how far you go and how far you drop. So you don't know your final position, or you can call it your initial position, it's up to you, and then you don't know x, but you know they're related here. So all you gotta do is make a substitution. Again, based on my coordinate system, it looks like I let the final height be 0, so I'm calling this 0, and the initial height I call x tan phi. So y naught is x tan phi, and I have x, and so then my only variable here is x. But once you know x, then you know y. Again, this is just a nice, easy trig relationship between x and y that takes you from 2 variables down to only 1 variable. Okay, 6 is an abstract one. It looks like I used two different ideas. So you want the range to equal max height. Oh, and what angle would that be? Okay, well, this is the range equation, and then this is the max height equation using the v squared. So if I want the range equal to max height, I just set these equal to each other. And this is just me doing some algebra. So I just did exactly what the problem said. I found an equation for range. I found an equation for max height. I set them equal to each other. I got rid of things, right? G canceled, V naught canceled, and I left with this. And this is something you can just solve using your graphing calculator. So graph that and you find that angle. Okay, and what I'm saying is then if you launch something at that angle, the range in meters will be the exact same as the max height. All right, last one. 7. Okay, this looks like I'm launching 2 different things. Okay, number 1, a ball's here and it gets launched 15 meters per second at a certain angle. Over here at a certain distance, 20, another person stands on top and they throw it horizontally, which is important. And I want them to collide. Remember, I discussed in class, if you want things to collide, you want their heights to be equal when their x values are equal. Okay, so let's just write these out. This is the x position for this guy, and this is the x position for number 2. Now remember, number 2 was already 20 meters over, so he had a starting position, and then he threw it left, so I had to use a -5, and he threw it horizontal. So all of his velocity is horizontal. So vertically, this guy's as if it was just dropped, right? He has no vertical velocity at the beginning, so it's just an h minus 1 half gt squared. And then this guy's the standard projectile motion equation. These two tell me that they have the same x value at an exact point of 1.21 seconds. So then all I did is I took these heights and I set them equal to each other at 1.21 seconds, and then the only variable left was h. And so that exact height made it so they were the same y values at that time, and that time was me setting the 2 x values equal to each other. And that's what it means to collide. All right, this last one is probably the hardest one just because it's in the abstract. And this is an AP question that I really like. So a ball bounces down, and what you do need to know is that when a ball bounces on a 45-degree ramp, it will be launched horizontal, meaning the angle of incidence and the angle of reflection are the same, and that makes it horizontal launch. And so then the rest of it kind of, is pretty easy. So remember, the ball is launched horizontal in this particular case because of the particular angle they gave you. Okay, so from the v squared equation, you can figure out how fast it's going to be traveling right there. It's all just based on the v squared equation, right? That's 0, and that's 2gh. So the velocity there is just this. I think I do time later on. I think this is time here. The distance along the path. Okay, so speed. Oh, speed. I do this in all sorts of crazy order, right? Here's the speed. That's what speed, the definition of speed, right? It's the Pythagorean theorem of the 2 vectors, and I find those 2 vectors out. But analyzing it from here, it looks like my work is really right here. So vertically what happens, again, horizontal launch, so vertically it's just h equals 1 half gt squared, and then horizontally it's just x equals vt, where v naught is right here. Okay, so then I basically do the same thing I do in the skier position. If this is L and this is 45 degrees, then the height is L sine theta, and the horizontal distance covered is L cosine theta. Okay, and so then I can manipulate those things. Again, if you look here, you only have 2 variables, right? You have t and you have L, and the square root of 45 is the square root of 2 over 2, and you can solve for t, and everything drops out. And again, there's just a little algebra here that this is the square root of g over g, which is really just the square root of g in the denominator. Once you know time, then you can find the length, You can find the velocities at that moment in time, so you can kind of find everything. Again, I understand that this one is a little difficult because it's in the abstract, but you do the same thing if you had a number. If I asked you to find the speed, you would find Vx and Vy and do the Pythagorean theorem. Now, if I had you analyze the skier question, again, look back on the skier question. It's basically the same thing here. It's a horizontal launch, so that's the vertical, that's the horizontal. Relate them to each other with the ramp, and kind of go from there. So some of these simplifications might be a little challenging, but it's really just square roots and fractions. So just take your time and kind of work through it. Okay. Hopefully this video helps you get ready for the test. I think the review asks 8 really good questions that all kind of cover all the relationships and formulas that you should be able to do on the test.